Hi guys, so in this problem or this video we'll go over problem 7F from the calculus IB style questions. We're given that y equals 2x to the third minus 9x squared plus 12x plus 2 equals k has three solutions. Find the possible values of k. Let's try to understand first what it's saying here. So basically, graphically, algebraically what this means is I'd get three x values if I knew how to solve this algebraically. Graphically, what it means is that if I had a graph of 2x to the third, blah, 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 it might look like something like this, right? And then, so that's this piece. We're saying when this equals to k, another function, which will just be a horizontal line. And what we're saying is that when it is equal to k, it has three solutions, which means if I graphed both of them, right? So we're trying to find out what is this k value such that there will be 3 points of intersection with my function, with this function. So what we want to do is graph it, and then maybe that'll help us see it a little bit better. Okay, so I entered my equation, and then I pressed graph, and you can see this is what it looks like in a standard window. You see how like the interesting curvy parts are up here. So I'm going to change my window so that I just focus in on there, right? So I don't need any of the second quadrant, or any of the third quadrant, or any of the fourth quadrant. I only really need the first quadrant. So I'm going to change this to from 0 to 10 and from 0 to 10, and that should focus in on the first quadrant right there. I don't even need to go that far right, so maybe I'll only go to 5 on the x-axis just so it's nice and big and centered in the front of my screen. So it wants to know for what values of k will there be three here, that in order to intersect 3 times it has to hit this curve twice and this curve once, right? Or like it's going to be somewhere between the relative min here and the relative max there, right? Because if you start drawing them up here, then there's only one. If you start drawing those horizontal lines down here, there's only one, but only in between those two relative maxes are you going to have 3 points of intersection, right? So basically what it boils down to is you need to find the relative maxes, a relative max and a relative min, which we can do that by doing second trace. Let's do the maximum first, so it'll be 4. The maximum is over here. So you start at the maximum, it says go left bound, so we're going to go left a few clicks, press enter. Right bound, go to the maximum, press right, enter, and then guess, somewhere close, enter, right? So this maximum occurs at x equals 1, y equals 7. Right, so this point up here is 1, 7. Right, then we do second trace minimum. Again, start at the minimum, go left a little bit, press enter, start at the minimum, go right a little bit, press enter, and then guess, press enter, and we get 2, 6. So this one occurs at 2, 6. So we have our points 1, 7 and 2, 6. What we're concerned about here is the y values, because this is you know what y values will y equals k is the horizontal line, and so k must be 6, not including 6, not including 7, because if you include them, then it's only 2 points of intersection, right? 1, 2, and that's only 2 solutions. So you can't include 6 and you can't include 7, right? And I think that's it for that one.